Hello everyone, welcome to OpenGeology. We are starting the CIL PYQ solutions. So the question paper happened in 2017 and we will see the part 2, that is geology section. So this is the first video and we will see question number from 1 to 10. Okay, so but before you begin, you can join our CIL Geologist test series. So we will have around 100 plus tests and with the detailed solution from part 1 and paper 2 as well. So we are covering all of the things whatever will come in the CIL test series. You can also join the Geologist, GATE, GSI and other test series as well. So let's see the first question. The Goldsmith mineralogical phase rule states that number of phases is equal to the number of components. That means P is equal to C. Now, which of the following assumption in the above statement is correct? So, the correct option is B, the degree of freedom is 2. Now, let us see how it will happen. So, the formula is F equal to C minus P plus 2. Now, P is equal to C as per the question. So, it will become F is equal to, you can say C minus C plus 2 and F equal to 2. So the degree of freedom will be 2. Second option will be our correct answer. So what you can read, you can use this phase rule and apply in the 1 component system, 2 component system, 3 component system. You can use the eutectic system, peritectic system. So all of these systems you can try to use this mineralogical phase rule. Then second question is when rock is partially melted. When rock is partially melted, the chemistry of the melt, what will happen to the chemistry of melt? So it will become more felsic than the original chemistry of rock that was partially melted. Now why this happens is, it is because whenever the melting happens is, the first mineral that will be melted are SiO2, sodium, potassium or aluminium rich. So all of these, like you have you can say the silica, quartz minerals and all of the aluminium minerals, clay minerals, they becomes vulnerable and they melted first. So that is why increase in the aluminium and silica content makes them more felsic. Okay, so what you can cover the topics from this question, you can cover what are the felsic rocks, what are the mafic rocks, what are the felsic minerals and what are the mafic minerals. Okay, so these things you can cover. Then next question is about the lithostatic stress on a horizontal plane at the base of a continental crust, while the thickness is 35 km and density is 2750 kilogram per cubic meter. So simple, it is a lithostatic stress. So it is sigma equal to rho GH. You know the rho, it is 2750. So 2750 into G, you can take 9.8 or simply you can take 10 for easier calculations, and the height, that is 35. So finally your answer would be 9.446 into 10 to the power 8 pascals. And if you will convert that's into the megapascal, which is our answer, so it will become 962.5 megapascal. So third option will be our correct answers. So this question can also represent a topic known as isostasy. Okay, so you should try to cover the numericals from the Airy's hypothesis and the Pratt's hypothesis. Okay, then next question is related to the upliftment of Himalaya. So upliftment of Himalaya happens and the Tibetan plateau have contributed or even caused the global cooling. Now the link between these two, the upliftment of Himalaya and the climatic cooling, how this happens and how they are related. So the upliftment intensifies the monsoons because it acts as a barrier to the monsoon and associated physical and chemical weathering. So if it intensifies the monsoon, then more rain will happen and more physical weathering can happen. More water is there, so more chemicals are there, so they can dissolve into the water and cause the further disintegration and the erosion happens. So this results in the withdrawal of carbon dioxide from the atmosphere and leads to the cooling. So first option will be the right answer. Then question number 5. Where does most of the continental topography lies between? So this is not a numerical, it's simply a concept or the factual question that it lies between the sea level and 1 kilometer above the sea level. Another question is why the bombardment is an essential process in the history of a planet. So it is important because this is how a planet grows. The residual heat from the impacts may help to create a dynamic planet, because sometimes plate tectonics are affected by these bombardments and the craters are made. You have the several lakes like the lunar lake. So these all are the history of planets. If you see the moon, what happens is with moon there are continuously bombardment and creating a lot of craters. So this is history. The many times there were bombardment events and few of them are recorded, few of them are eroded. So it is important for a dynamic planet. The next question is what is the radiometric resolution defined as? So what happens is if you have let's say a frequency, you have the frequency from 1 micrometer to 5 micrometer. Okay, now if you have a sensor and it cannot differentiate between this 1 micrometer and 5 micrometer, and you have another sensor, let's say sensor number 1, then you have another sensor that is sensor number 2, it can differentiate between the 1, 2, 3, 4 and 5. So this sensor you can say is having more resolution. It can identify a slight change in the intensity. So this is how the radiometric resolution is defined. So if you will go the exact definition, so the sensitivity of a remote sensing detector to measure the magnitude of electromagnetic energy is known as the radiometric resolution. Okay, so the smallest change in the magnitude, like from 1 to 2, if it can detect, then it has a high resolution as a radiometric resolution. Now what you can learn about the different type of resolution, like what is spatial resolution, what is radiometric resolution, and other type of resolutions as well. And one thing you can also read, that is scale. Okay, what is scale? The different scales into RF. If let's say if a feature is of 1 kilometer length, how much it will be represented in a map or in an image with a scale of 1 is to, let's say, 100. So these things you can learn, that is important for the exam point of view. Now another question, question number 8. Two limbs of a fold, when plotted as a planes on a stereographic projection, these intersect each other twice before the intersection point lying on the periphery of the stereo net and dramatically opposite to each other. Now the fold is, you have to understand that this is a horizontal non-plunging fold. Let me create one fold. Okay, so this is one fold and this is a fold axis. Fold is something like this. Okay, so it is something like this, you can like this. Okay, and this is the okay, the axial plane. Now let's say that this fold have a dip of 10 degree. Okay, and another have the dip of, let's say, different, that is 5 degrees. Now how they will be plotted on a stereo net? Let's say this is our stereo net. Okay, and let's say they are dipping both on eastern side. Okay, this is the north, this is the south. Now let's plot first the 5 degree. So this is how a 5 degree plot will happen. Okay, now let's say Then another is 10 degrees. So let's say this 10 degree have a little bit slightly different orientation. So it will come like this. So the steeper it is, it will go closer to the center. So it will intersect 2 times before intersecting the periphery. So a horizontal non-plunging fold will be the correct answer. Now another question is the chemical reaction which transforms feldspar into the clay mineral. Now what will happen in this case? The hydrolysis is the chemical process. Now what is hydrolysis? So the hydrolysis is a reaction which water breaks chemical bond in a mineral, changing into new mineral. So whenever water interact with a mineral, it will break the mineral. It will break the mineral bonds, and that will leads to change the chemistry, and a new mineral will form. Now, what are the other things that you can remember? You can remember the hydration. Okay, you can remember what is dissolution, what is hydrolysis, and what is the oxidation. Okay, so these things can also be asked in the CIL exam. Now one thing that I missed is okay, here what you can learn extra for this exam, you can learn the basic concepts of dip and strike. Okay, the dip direction, strike direction, they are perpendicular to each other, and you can learn the basics of the stereonet. Okay, basics of the stereonet. So these two things you can learn. Then another question is the last question. A swing door in a wall aligned north south, it would swing in response to which component of the ground motion? So let's say a swing door is aligned north and south. Let's say this is our room and this is the door. Okay, now it is aligned in the north and south direction. This is the north and this is the south direction. Now if it will go that way or that way, so it will swing in the east and western direction. Okay, so door is aligned to the north south, it will swing in the east and west direction. So the correct answer would be B, east and west. And this question is from the different you can say the structural processes like the dilation, rotation. Okay, and dilation, rotation, the straight movement, curvilinear movement. So all these things you should remember their examples like the stress, strain. So these things will come as per this question concept. Okay, so it's all about for today. We'll see you in the next video with next questions, and till then keep ready, keep preparing for the CIL exam, and join us the CIL test series for paper 1 and geology. So you will get 100 plus test and 5 full the 6 7 9, a total of 9 full length tests. Okay, and this will cover most of the part, so it will help you to boost your preparation and succeed in the exam. So thank you.